Welcome back to the deep dive. We have a stack of papers on the virtual desk today that are, well, they're going to break your brain a little bit.
Just a little.
But I promise, in a good way. We are tackling a question that usually belongs in a sci-fi novel, but today it's grounded in a really ambitious, dense piece of theoretical physics.
It is. It's the ultimate what if.
And the question is this: what if everything we think is stuff? Electrons, quarks, light, gravity, the chair I'm sitting on, isn't actually made of anything at all? What if matter is an illusion and the only thing that's real is geometry?
Sounds like a philosophical dorm room conversation, doesn't it?
It really does.
But we're looking at a paper titled Supersymmetric Geometric Quantum Mechanics, or SGQM for short, by Aaron Buchami. And this isn't just philosophy. This is a full-on mathematical framework that tries to say, stop looking for the actors, look at the stage.
That's a great way to put it. We usually think of the universe as a container. Space is the box, time is the clock ticking on the wall, and particles are the little billiard balls bouncing around inside the box.
Precisely. That's the Newtonian view, and even to some extent the Einsteinian view. But SGQM says, throw the billiard balls away, there are no actors.
Wow.
There was only the stage. But, and this is the key, the stage is alive. It twists, it knots, it rotates. And what we perceive as a particle, an electron, a photon, is just a specific type of knot in the floorboards.
I love that image, a knot in the floorboards. Now, before we get into the heavy math, and there is some heavy math in this Aetheron model, I want to set the scene, because the motivation behind this paper is really the holy grail of physics.
A unification problem.
Right. We have quantum mechanics, which rules the tiny stuff atoms, subatomic particles. It's chaotic, it's probabilistic, it's weird.
Extremely weird.
Then we have general relativity, which rules the big stuff stars, galaxies, gravity. It's smooth, predictable, geometric. And famously, these two theories hate each other.
They are the oil and water of physics. If you try to use quantum mechanics to explain a black hole, the math just breaks down.
It gives you nonsense.
Total nonsense. And if you try to use gravity to explain an electron, the math gives you infinity, which is basically the universe saying error does not compute. They refuse to talk to each other.
But Buchami claims he's found the emulsifier. He thinks he can mix the oil and water by zooming out to a 12-dimensional framework. And what struck me reading the intro to this paper was the personal story behind it. It wasn't just, I did some calculus. It starts with a childhood memory.
The blackboard of nothingness.
Yeah. He talks about being a kid, lying in bed, pressing his eyes into his pillow until he saw those phosphine patterns, the little fractals and colors you see when you rub your eyes.
Sure, the visual noise of the optic nerve.
He was trying to visualize nothing. He was obsessed with what empty space is. He describes listening to his parents debating time and relativity in the kitchen while he was lying on the floor, trying to imagine the architecture of the void.
It really creates this image of a mind that wasn't just learning the equations by rote.
Right.
He was trying to visualize the machinery of reality from a very young age. And you see that visual approach all over this paper. He's not just throwing algebra at us. He's asking us to visualize rotating triangles, spinning shapes, and geometric locks.
So let's get into the meat of it. The core concept is something he calls the Aetheron. Now I have to pause here. When I hear aether, I immediately think of men in top hats in the 1800s talking about the luminiferous ether.
Which we know is wrong.
Right. Completely wrong. Einstein and the Michelson-Morley experiment killed that idea 100 years ago. So is Buscemi trying to drag us back to the Victorian era?
It's a crucial distinction, and he makes it very clear in the paper. The old 19th century ether was thought of as a fluid.
An invisible ocean?
Exactly. An invisible ocean that the Earth and planets were swimming through. And the idea was that if we're moving through this ocean, we should feel a wind against our face, right? Just like sticking your head out of a car window.
And Michelson and Morley built this incredibly sensitive device to measure that wind and found absolutely nothing.
Zero wind. Exactly. So they concluded the ether doesn't exist. But SGQM brings back the word, but not the definition. The Aetheron isn't a fluid you move through. It is a geometric field that is space-time itself. You can't feel a wind because you aren't moving through it. You are a part of it.
Okay, help me visualize that. If it's not a fluid, what is it?
Think of it as a lattice, a structure, specifically a 12-dimensional structure. The paper calls it a dynamic rank 2 tensor field.
Which is a bit of a mouthful.
It is. But tensor is just a fancy math word for something that can stretch and hold tension like a fabric. But this fabric can twist And most importantly, it can rotate.
And the claim is that everything, mass, energy, gravity, is just different ways this fabric is rotating.
Precisely. And this leads to the central aha moment of the entire model. The paper argues that light doesn't travel.
Okay, hold on.
And gravity isn't a force pulling you. These are illusions caused by the way the geometry synchronizes.
Which sounds insane. Light doesn't travel. I mean, I turn on a lamp, the room lights up, it feels like something traveled.
It sure does.
We're going to get to that non-propagation hypothesis in a bit because I need to understand how my eyes work if light isn't moving. But first, we have to look at the engine of this model. The paper keeps coming back to one thing, the Pythagorean theorem. A thalers plus B2 equals C22.
It is surprisingly central. Usually we think of Pythagoras as a tool for carpentry or measuring distance on a flat map.
Yeah, for building a house.
But in SGQM, it's the code of the universe. Guccemi presents this core equation, and it looks just like it. Alpha 2 plus E2 plus E rho 2.
Okay, let's unpack the variables here so we don't lose anyone.
Yeah.
We have a right triangle. What are the sides?
So imagine a right triangle. You have the hypotenuse, the long diagonal side. In this model, that hypotenuse is alpha.
Alpha.
This represents the fine structure constant.
Okay, I remember this from physics class. The fine structure constant. It's usually written as what, 1 over 137?
Roughly, yes.
And it basically tells us how strong electromagnetism is. It's one of those magic numbers of the universe.
It is. In standard physics, it's just a number we measure. We don't know why it is that number. It's just there. If it were slightly different, atoms wouldn't hold together. But in this model, alpha isn't random.
It's the hypotenuse.
It is the hypotenuse of reality. It represents the total conserved rotational state of an Aetheron unit. It's a fundamental geometric ratio.
So the size of the reality triangle is fixed by this alpha number. What are the other two sides, the legs?
The two legs of the triangle are Muffer, which represents mass, and Inapruwat, which is rotational energy.
So mass and energy are the two legs of the triangle.
Yes. And because it's a right triangle, they are orthogonal.
Orthogonal. That word comes up again and again in this paper, 90 degrees apart. Why does that angle matter so much?
It changes everything about how we view matter and energy. Einstein gave us EMC22 Severage.
The most famous equation in history.
Right. And it tells us mass and energy are equivalent. They can turn into each other. You burn a log, mass becomes energy. But SGQM says they aren't just convertible, they are supersymmetric projections.
I need an analogy. Supersymmetric projections is a mouthful.
Okay, think of a shadow. Imagine you have a complex 3D object spinning in the air. Let's say that's the Aetheron unit. Now shine a light on it from the front and cast a shadow on the wall behind it. The shadow looks like a square.
Okay, that's mass.
Let's call that mass. Now keep the object spinning, but move your flashlight to the side 90 degrees away. Shine it again. Now the shadow on the wall looks like a circle.
And that's energy.
That's energy. The object itself, the Aetheron, represented by alpha, never changes size or shape. It's just spinning.
Yeah.
But as it rotates, what we see in our dimension, the shadow, changes. Sometimes you see less square and more circle.
Less mass, more energy.
Or vice versa.
Yeah.
They're just two different perspectives of the same underlying rotation.
That creates a really intuitive conservation law. If the mass side of the triangle gets longer, the energy side has to get shorter to keep the hypotenuse the same length.
Exactly. It forces balance. And this geometric 90-degree offset is what creates the distinction between the two main types of particles in the universe. Fermions and bosons.
Fermions are matter, right? The stuff I'm made of, electrons, protons.
Right, the hard stuff.
Right.
And bosons are the force carriers. Photons of light, gluons, the stuff that makes things happen.
So they're not different ingredients.
In this model, no. They are not different ingredients in the cosmic soup. Matter, fermions, is just the Aetheron rotating in a way that projects mass onto our reality. Force bosons is the Aetheron rotating in a way that projects energy. They're just different dance moves performed by the same dancer.
So if I could somehow grab an electron and twist it 90 degrees in this higher dimensional space, it would turn into a photon, into light.
Theoretically, yes. That is the essence of supersymmetry in this model. It's a geometric rotation, not a magical transformation.
Okay, speaking of twisting things in higher dimensions, let's talk about the stage again. We mentioned 12 dimensions earlier. I feel like every time we cover physics, the number of dimensions changes. String theory has 10, or 11, or 26. Why 12?
It's not just an arbitrary number picked out of a hat. The model is very specific. It breaks it down as 4m polar times FD8.
4m por is us.
Yes. 4m polar is Minkowski space. That's the technical term for the world we live in. 3 dimensions of space up, down, left, right, forward, back, and 1 dimension of time. That's the grid where you drive your car and drink your coffee.
And the $58, that sounds like a function key on a keyboard.
Yeah, it does. It stands for the fiber. It's an internal 8-dimensional space that exists at every single point in our world.
At every point.
At every point. But don't think of them as tiny curled up balls like in string theory, where they are just hiding. In SGQM, these 8 dimensions are active. They are rotational axes. The paper labels them R1 through R8.
R1 through R8, like keys on a piano.
That's a fantastic comparison. Imagine every point in empty space has a tiny, invisible 8-key piano. Depending on which keys or axes are striking or spinning, you get a different particle.
So if I play a chord using keys R1 through R4,
You get a fermion, a piece of matter. The paper assigns those lower axes to the matter sector.
and if I switch to the upper register, keys R5 through R8.
You get a boson of force. Those are the force sector axes.
This makes particle physics sound like music theory. An electron isn't a little ball, it's a specific chord being played on axes R1 through R4.
It's a specific resonance, a stable rotational pattern.
You know, that actually reminds me a bit of high school chemistry.
Oh yeah, how so?
Do you remember the electron shells, that rule, the 2 and 2 and 2 rule?
The Bohr model, sure.
Yeah, exactly. We learned that the first shell, it can hold 2 electrons. The next shell up holds 8. Then 18. It wasn't random. There were these very specific integer-based slots where things had to fit.
That is a brilliant parallel to draw. In chemistry, the 2n2 and 2,2 rule dictates the capacity of an energy level. It's a constraint. An electron can't just hang out somewhere in between.
Right, it can't be in shell 1.5.
It has to be in a valid shell.
Right.
SGQM is applying that same logic, but to the fabric of space itself. The F8 fiber, with its 8 axes, acts like a set of available slots or orbitals for rotation.
So the dimensions are like the shells.
In a way, yes. You can spin on R1 or you can spin on R2. You can't spin on R1.5. This integer-based structure is what quantizes the universe. It's why we have quantum mechanics.
Because it comes in discrete packets.
It's discrete, not continuous, because the geometry only allows certain stable chords to be played. It's the fundamental reason for quantization.
Okay, so sticking with this idea of stable chords or knots, let's look at the 720-degree cycle. I circled this in red ink because it makes my head hurt.
It makes everyone's head hurt the first time.
Why 720 degrees? A circle is 360 degrees. If I spin around in my chair once, I'm back where I started. Why does the universe need to spin twice to get back to the start?
This is actually a known, empirically true thing in quantum mechanics called spin 12. If you take an electron and rotate it 360 degrees, it doesn't actually look the same mathematically.
It's different.
Its wave function is inverted, its phase is flipped. You have to rotate it another 360 degrees, 720 total, to get it back to its original state. Standard physics just accepts this as a weird rule of the universe.
It's like the universe has a twisted sense of direction.
The SGQM model gives a geometric reason for this. It calls it the dual boson structure. And this is where the visualization gets fun. Imagine you have 2 hula hoops.
Okay, visualizing hula hoops.
Take one hula hoop and spin it. Let's say that represents a boson. It has a simple 360-degree cycle. Now, take a second hula hoop and place it inside the first one, but at a 90-degree angle orthogonal.
Like the skeletal structure of a sphere, a gyroscope kind of shape.
A gyroscope is a perfect image. Now spin that one too. You have 2 linked orthogonal rotations. The paper argues that a fermion, a particle of matter, is literally constructed from these 2 orthogonal boson fields spinning together.
So matter is just woven light. Or woven force fields.
Essentially, yes. A self-sustaining knot of 2 interlocked rotations. And because you have these 2 interlocking rings, the geometry is complex. To get that entire structure to reset to its original configuration, where both rings are back to start and the orientation between them is correct, you have to traverse a 720-degree path.
The paper breaks this down into 4 phases, right? Like a little dance.
Yes. It's a 4-step dance. A full cycle is 4 180-degree rotations. Phase 1 and 3 are where the mass and energy components swap.
Like the shadow analogy.
Exactly. And phase 2 and 4 are where the handedness, the orientation or chirality of the particle flips. You need all 4 steps to close the loop. 4 times 180 degrees is 720.
So a particle isn't a static thing. It's a process. It's the loop of geometry constantly turning inside out and back again.
Yes. And that constant turning, that complex spin, is what gives it mass. In this model, mass isn't just weight. It's persistence. It's the gyrostabilization of that dual spin. It resists being moved because it's so busy spinning.
That's a beautiful way to think about inertia. It's just geometric stubbornness.
I like that. I'm going to use that. Geometric stubbornness.
Okay, I'm with you on the spinning knots. I can visualize the hula hoops. Now, let's get to the part that made me stop walking when I was reading this, the non-propagation hypothesis.
This is the real mind bender.
The paper says light does not travel. And I have to say it again because I look at the sun and the light takes 8 minutes to get here. We bounce lasers off the moon and measure the timing. We have fiber optic cables sending data across the ocean.
All right.
How can you look me in the eye and say light doesn't travel?
Okay, think of the wave at a baseball stadium.
Okay. Thousands of people, stands, beer, hot dogs.
Someone starts the wave, they stand up, raise their hands, and sit down. Then the person next to them does it. Then the next. The wave moves across the stadium at a specific speed.
You can even time it.
You can measure the speed of the wave. But does any single person run across the stadium?
No, they just stand up and sit down on their own seat.
Exactly. In this model, the Aetheron, the geometric fabric, is the crowd. The photon is the wave. A photon isn't a bullet flying from the sun to your eye. It is a coordinated adjustment of the geometry. Point A twists, which causes point B to twist, which causes point C to twist. The twist moves, but the fabric stays put.
So the speed of light isn't the speed of a projectile.
No.
It's the reaction time of the crowd.
It's the synchronization rate of the universe. It's the refresh rate of the screen. The lattice can only adjust its geometry so fast. That limit is $1.
It actually makes a lot of sense. It explains why the speed of light is constant for everyone. It's a property of the medium, not the thing that's moving.
Precisely. It doesn't matter how fast you're running towards the wave in the stadium. The wave itself is still moving at the same speed relative to the stadium.
And this resolves the Michelson-Morley confusion we talked about earlier.
It does. They were looking for an ether wind. They thought if Earth was moving through the ether, light should be blown off course, like a boat in a current. But if the Aetheron is geometry that is space, you don't move through it. You are a knot in it. There is no wind. There is just the changing geometry.
This also has huge implications for connection. If light is just the fabric updating itself, does this explain quantum entanglement?
You're one step ahead, yes.
Because that's the other thing that breaks physics. Two particles, light years apart, reacting instantly to each other. Einstein called it spooky action at a distance.
SGQM calls it rotational memory.
Rotational memory.
If two particles are entangled, it means they were formed from the same initial geometric event. They share the same knot structure in the 12-dimensional fiber. In our 3D world, our M404 projection, they look far apart. But in the internal dimensions, that FEV one on space, they are literally the same object.
Oh, I like that. It's like two puppets on a stage that look separate, but if you look up into the rafters, the strings go to the same hand.
That's a perfect analogy. And because the connection is geometric, it doesn't require a signal to travel back and forth. You don't need to send a radio wave from particle A to particle B. You just twist the geometry here, and since they are part of the same geometric structure, the other one twists there.
Instantly.
It's instantaneous because in the higher dimensions, there is no distance between them to cover.
This implies that distance is kind of an illusion, or at least just a low-resolution projection of a much tighter reality?
That's a fair way to put it. We see the separation, the universe sees the connection.
All right, we've deleted light travel. Let's delete gravity while we're at it. The paper says gravity is geometric guidance.
This is where Buscemi aligns with Einstein, but goes a layer deeper. Einstein said gravity is a curved space. You put a bowling ball on a trampoline, the trampoline curves, and a marble rolls toward it.
Standard high school physics model.
Right, and it's a great model.
Yeah.
But SGQM asks, how does the marble know to curve? It doesn't have eyes. It doesn't see the curve. It says gravity is a phase-locking mechanism. Remember those rotating axes R1 through R8?
Your piano keys.
Right. When a massive object sits in space, a big Aetheron knot like a planet, it twists the fabric around it. Specifically, it puts a lot of tension on axis R7, which the paper identifies as the curvature axis.
Okay, so the Earth is sitting there cranking hard on axis R7.
Now, a smaller particle, you, me, a satellite, comes along. Its own internal clock, its rotational phase, has to sync up with that twisted environment.
It has to get in tune with the local music.
Exactly.
Yeah.
To stay in sync, to keep its Pythagorean balance that we talked about, it has to change its trajectory, resync its spin. That resyncing looks to us like falling.
So I'm not falling toward the Earth because the Earth is pulling me with some invisible rope.
No.
I'm falling because my internal geometry is trying to harmonize with the Earth's geometry.
You are geometrically tuning yourself to the local environment. It's not a force. It's a synchronization requirement.
And there's a number here, $8, a type high. The paper makes a big deal about this in the gravity section.
It does. In Einstein's field equations, you see the term $8 G dollar. In most textbooks, it's treated as just a scalar constant. You need to make the units work out.
It's just a number.
SGQM says, no, look at the geometry. We talked about the 720-degree cycle, which is 4 pi radians, for a fermion.
Right, the double spin.
Well, gravity is a tensor field. It's more complex. It interacts with the whole shape of space.
Mm.
To get a fully stable, closed universe that includes both matter and gravity, you need a double cycle.
Yeah.
2 720-degree cycles.
Math check. 2 times 720 is 1440 degrees. And 1440 degrees is...
The A-tire in the gravity equation isn't a random number. It's the signature of the full rotational closure of the universe. It's the master cycle.
Oh.
If it were any other number, the geometry wouldn't close properly and gravity wouldn't be stable.
That is wild. It's like finding out the number of stitches in a baseball tells you the rules of the game. It's not arbitrary, it's structural.
It gets even more specific.
Mm-hmm.
This model makes a prediction. A real, testable prediction about Mercury.
Mercury is the trouble child of the solar system.
Always has been.
Its orbit wobbles in a way Newton's gravity couldn't explain. Einstein fixed it with relativity.
Correct. Einstein fixed it by saying space is curved near the sun and Mercury is just following that curve. But SGQM says, wait, there's more. The paper talks about magnetic leakage.
Magnetic leakage? This sounds like a problem with a hard drive.
Remember the axes. R6 is the electromagnetic coupling axis.
Got it.
R7 is the gravity axis. In the internal AD fiber, these axes are neighbors. They're physically connected in the lattice structure.
Okay, like 2 adjacent keys on the piano?
A great way to think of it. The sun has a massive magnetic field. That means the sun is cranking hard on axis R6. SGQM predicts that because R6 and R7 are linked in the geometry, the sun's magnetic intensity will drag on the gravity axis. It's like pressing one piano key so hard that the one next to it vibrates a little.
So the sun's magnetism is messing with Mercury's gravity.
Subtly, yes. The model predicts that Mercury's wobble, its precession, should vary slightly depending on the sun's magnetic cycle. When the sun is magnetically active at a solar maximum, the wobble should change. Standard general relativity doesn't predict that. It says gravity is gravity regardless of magnetism.
That is a smoking gun.
It really is.
If astronomers look back at the historical data and see Mercury wobbling differently during a solar maximum versus a solar minimum, Buscemi is right.
Or at least he's on to something that general relativity is missing. It's a very bold claim because it challenges the purity of Einstein's gravity.
I love a bold claim. Let's talk about the invisible elephant in the room. Dark matter. Every astronomer tells us most of the universe is missing. We can't see it, but we feel its gravity holding galaxies together. What does the Aetheron Model say about this?
It calls them dark bosons, and it's a brilliant application to the R-axis system we talked about.
How so?
Okay, think about the piano keys again. To interact with light, to be visible, a particle needs to activate axis R2, which the paper links to charge phase, and axis R6, the EM coupling axis. If you don't spin on those axes, you are invisible. You cannot absorb or emit light.
You're a ghost of photons.
Right. But to have mass and gravity, you need axis R3, mass, and R7, curvature.
Okay, following you.
SGQM proposes a type of knot that can form only using axis R5 through R8.
So it's using the force axis, the upper register on the piano?
Yes, specifically the bosonic sector. It locks into a stable knot using R5, R7, and R8. It skips R2 and R6 entirely. It has no interaction with the electromagnetic axis.
So it has R7 gravity, but no R2 or R6 light interaction.
Exactly. It creates curvature. It has mass. But it is geometrically incapable of interacting with light. It's not just dark because it's hiding behind a dust cloud. It's dark because it lacks the geometric hardware to touch a photon.
It's electromagnetically silent, but gravitationally loud.
That's the phrase from the paper. And it suggests these aren't exotic alien particles floating around. They're just a different stable state of the vacuum geometry. It's like a different chord on the piano that we just can't hear, but we can feel the vibration in the floor.
And what about the strong force? The glue holding the nucleus together. Usually we talk about gluons being exchanged.
SGQM calls this lattice tension. Imagine the Aetheron lattice again, like a grid of rubber bands. If you create a knot of quark, it twists the lattice tight around it. If you try to pull two quarks apart, you're stretching the geometry between them.
Like stretching that rubber band.
Yes. And eventually the tension gets so high that the energy required to stretch it further is actually enough to just create a new knot. The rubber band snaps and forms two new loops.
Ah, so that's confinement.
That is confinement. It's why you never see a quark by itself. The geometry literally won't allow the lattice to stretch that far without snapping into a new particle.
So gluons aren't particles flying back and forth. They are the stress lines in the fabric.
They are the shear stress of the Aetheron.
This changes the whole picture. We usually think of physics as, here is a particle, and it shoots a force beam at another particle. This model says, here is a twisted spot in the fabric, and the tension in the fabric affects the other twisted spots.
It moves us from a physics of objects hitting objects to a physics of relations and harmonies. It's almost musical.
Musical.
Think about it. A particle isn't a solid dot. It's a resonance. It's a vibration, a specific frequency of rotation. The universe isn't a collection of billiard balls. It's a symphony. If the Aetheron is the instrument, the particles are the notes.
And the constants of nature, like the speed of light or the electron charge, aren't just random settings on a dial. They are the rules of harmony, the principles of the composition.
Right. Alpha, the fine structure constant, isn't just a number. It's the ratio that allows the music to be harmonious. If it were different, the geometry wouldn't close, the knots would unravel, the universe would dissolve into noise.
That is poetic, but also it feels cleaner. I've always been bothered by the idea that the universe just is the way it is because of random chance or the roll of a cosmic dice.
Yeah.
This says it has to be this way because the geometry requires it.
It points toward a deterministic structure, not in a no free will way necessarily, but in the sense that reality is coherent. It fits together like a puzzle. There's an underlying logic.
And it solves other problems too, right? Like singularities, black holes. Does a black hole break this model?
According to the paper, no. A black hole isn't an infinitely dense point. It's a topological phase transition. It's where the Aetheron lattice becomes so twisted by gravity that the normal rules of rotation, the 720-degree cycle, break down. It's a region where the geometry has a different operating system.
Music stops and it's just silence.
Or a different kind of music we can't hear.
So what does this all mean for us? For you listening, driving to work right now?
It changes your relationship with space. You aren't driving through space. You are space. You are an incredibly complex, stable, self-sustaining knot of geometry, moving through a field of geometry, interacting with other knots of geometry.
I am a knot in the floorboards.
A very sophisticated conscious knot, yes.
It also makes me think about connection. We talked about entanglement. If we are all just twists in the same continuous fabric, are we ever really separate?
The non-propagation idea suggests we aren't. If light doesn't travel between us, but rather the space between us updates to connect us, then separation is just a phase delay. In the 12th dimension, in that deep structure, the whole universe is one connected shape.
One rotating diamond.
One rotating diamond.
I want to leave you with a thought from the very end of our notes. It's about shadows. We talked about how mass and energy are shadows of the Aetheron. We only see the shadows. We measure the mass, we measure the energy, we see the 3D world. But the reality is that 12D structure is spinning in the dark.
Plato's Cave, updated for 2026.
Exactly. We are watching the shadows on the wall and calling it physics. We're arguing about the details of the shadows, but Buscemi is trying to turn us around to look at the light.
And the math suggests the shape casting the shadow is beautiful.
It certainly is. So the question becomes, if our reality is just the 4D shadow of a 12D rotating diamond, what does the rest of the shape look like? And if light doesn't travel, if we're all just parts of one continuous object, are we ever truly separated from anything else in the universe?
That's the thought to chew on.
This has been a heavy one, but hopefully a transformative one. We'll be back next time with another deep dive. Keep looking at the shadows, but try to see the shape casting them.
See you then.